Imagine, if you will, a universe devoid of twinkling stars, swirling galaxies, or even the very essence of matter itself. A cosmos of utter darkness and emptiness, stretching infinitely in all directions. Is this the ultimate fate that awaits our universe? Or does an even more dramatic destiny lie in store for the tapestry of space and time we call home? Welcome, intrepid explorers of the cosmos, to Zen Gaming Zone. In this podcast, we venture into the farthest reaches of scientific understanding to contemplate the greatest mysteries of our universe. I'm your host, Dev, and today, we're embarking on a journey that will take us billions of years into the future as we explore the potential fates that await our cosmic home. In this video, we'll delve into mind-bending theories that attempt to predict the ultimate destiny of our universe. We'll explore concepts that challenge our understanding of physics, space, and time itself. From the fiery collapse of the Big Crunch to the icy stillness of the Big Freeze, and even the cataclysmic tearing of the Big Rip, we'll examine the evidence for each of these cosmic scenarios and contemplate their mind-boggling implications. But our journey won't stop there. We'll also venture into even more speculative realms, considering the possibility of cyclic universes and the mind-expanding concept of the multiverse. Whether you're a seasoned astrophysics enthusiast or simply curious about the biggest questions in science, this episode promises to expand your cosmic horizons and leave you with a new perspective on the vast universe we inhabit. So fasten your seatbelts, engage your gravitational stabilizers, and prepare for a journey to the very end of time itself. Let's begin our exploration of the future of the universe. Before we dive into the various theories about the universe's ultimate fate, let's take a moment to consider where we currently stand in our understanding of the cosmos. For decades, astronomers and cosmologists have observed that our universe is expanding. This expansion, first discovered by Edwin Hubble in the 1920s, has been a cornerstone of modern cosmology. But in recent years, our understanding has become even more complex. Not only is the universe expanding, but the rate of this expansion appears to be accelerating. This unexpected acceleration, discovered in the late 1990s through observations of distant supernovae, led to the hypothesis of dark energy, a mysterious force that seems to permeate all of space, pushing everything apart. This accelerating expansion sets the stage for our discussion today. The ultimate fate of our universe hinges on the long-term behavior of this expansion. Will it continue forever? Will it slow down and reverse? Or will something even more dramatic occur? Let's explore the leading theories, starting with a scenario that was once considered the most likely: the Big Crunch. The Big Crunch theory suggests that the story of our universe will end much as it began, with an incomprehensibly dense singularity. According to this hypothesis, the expansion of the universe will eventually slow down and reverse, leading to a cosmic collapse where all matter and energy are crushed back into a state similar to that which preceded the Big Bang. To understand this concept, imagine the expansion of the universe as a ball thrown upward. Initially, it moves away from the ground rapidly, but gravity constantly pulls on it, slowing its ascent. Eventually, the ball reaches its highest point and begins to fall back to Earth. In this analogy, the ground represents the singularity, the ball represents the expanding universe, and gravity represents the attractive force of all the matter in the universe. The key to the Big Crunch scenario lies in the total density of the universe. If the universe contains enough matter, its combined gravitational pull could eventually overcome the force of expansion, much like the Earth's gravity eventually overcomes the upward momentum of our hypothetical ball. For many years, the Big Crunch was considered a leading contender for the universe's ultimate fate. It aligned well with our understanding of gravity and provided a certain poetic symmetry to the cosmos, a universe that begins and ends in a singularity. However, the discovery of the accelerating expansion of the universe has made the Big Crunch scenario seem less likely. For the Big Crunch to occur, the universe would need to contain significantly more matter than we currently observe. Current measurements suggest that the density of matter in the universe is below the critical threshold needed for a Big Crunch. Still, the Big Crunch remains a possibility, albeit a remote one. If our current measurements are off, or if there's a significant amount of dark matter that we haven't yet detected, the Big Crunch could still be in our cosmic future. The implications of a Big Crunch are profound and, frankly, a bit unsettling. As the universe contracts, galaxies would begin to collide and merge. Stars would be torn apart by intense gravitational forces. In the final moments, even atoms would be ripped asunder as all of existence is compressed into an infinitesimally small point. But some theorists see a silver lining in this cataclysmic scenario. The idea of a Big Crunch naturally leads to speculation about what might come after. Could the singularity at the end of a Big Crunch spawn another Big Bang, leading to a new universe? This concept, known as the oscillating or cyclic universe theory, suggests that our universe might be just one in an endless cycle of expansion and contraction. While the Big Crunch theory has fallen out of favor in recent years, it remains an important part of our cosmological understanding. It reminds us of the profound influence gravity has on the large-scale structure of the universe and highlights the crucial role that the density of matter plays in determining cosmic destiny. Now, let's turn our attention to a scenario that many cosmologists currently consider more likely: the Big Freeze. The Big Freeze, also known as the heat death of the universe, presents a cosmic fate that's almost the opposite of the Big Crunch. Instead of a fiery collapse, the Big Freeze posits a universe that expands forever, growing colder and more diffuse until it reaches a state of maximum entropy. To understand this concept, we need to introduce a fundamental principle of physics: the second law of thermodynamics. This law states that in any closed system, entropy, a measure of disorder or randomness, always increases over time. Applied to the universe as a whole, this law suggests that the cosmos is moving inexorably toward a state of maximum disorder. In the Big Freeze scenario, the expansion of the universe continues indefinitely. As space stretches, it becomes increasingly difficult for gravity to pull matter together to form new stars and galaxies. Over unimaginably long periods, existing stars will burn out, and no new ones will form to replace them. Picture the night sky billions of years from now. The once brilliant tapestry of stars slowly fades as one by one they exhaust their fuel and wink out of existence. Galaxies drift further and further apart in the expanding cosmic void. Even black holes, those cosmic behemoths that seem to defy the laws of physics, will eventually evaporate through a process known as Hawking radiation. As we progress even further into this unimaginably distant future, the universe becomes an ever-darkening, ever-cooling expanse. Atoms, spread so thin across the vast cosmic distances, rarely if ever interact. The universe approaches a state that physicists call maximum entropy, a condition where no usable energy remains and no work can be performed. This, in essence, is the heat death of the universe, a state of cosmic equilibrium where nothing happens because nothing can happen. It's a quiet, cold end to the universe, not with a bang, but with a whimper. The evidence for the Big Freeze scenario is compelling. The observed accelerating expansion of the universe, driven by the mysterious dark energy, seems to support this model. If this acceleration continues indefinitely, it would prevent the gravitational collapse necessary for a Big Crunch and instead drive the universe toward the state of maximum entropy described in the Big Freeze scenario. The implications of the Big Freeze are profound and, for many, deeply unsettling. It suggests a universe that ends not in a dramatic collapse, but in a slow fade to darkness and inactivity. It raises philosophical questions about the nature of existence and the ultimate futility of all cosmic processes. However, it's important to note that the timescales involved in the Big Freeze scenario are almost beyond comprehension. We're talking about time frames many orders of magnitude longer than the current age of the universe. The heat death wouldn't occur for trillions upon trillions of years. From a human perspective, it's an almost inconceivably distant future. Moreover, some theorists have proposed potential escapes from the Big Freeze. Perhaps the nature of dark energy could change over time, altering the expansion rate of the universe. Or maybe, as we'll discuss later, our universe is part of a larger multiverse structure that operates on principles we don't yet understand. As mind-bending as the Big Freeze scenario is, our next theory takes the concept of cosmic expansion to an even more extreme conclusion. Let's explore the idea known as the Big Rip. Imagine a universe where the force driving cosmic expansion becomes so powerful that it overcomes all other forces, even those that hold matter itself together. This is the premise of the Big Rip scenario, a theory first proposed in 2003 by cosmologists Robert Caldwell, Mark Kamyankowski, and Nikolai Sivkov. The Big Rip hypothesis is based on a particular understanding of dark energy, the mysterious force driving the accelerating expansion of the universe. In this scenario, dark energy isn't a constant force, but one that grows stronger over time. Cosmologists refer to this as phantom energy. As this phantom energy increases in strength, it begins to overpower the other fundamental forces of nature. The first to fall would be gravity, the weakest of the fundamental forces. Without gravity to hold them together, galaxies would be torn apart, their stars flung into the void. But it doesn't stop there. As the phantom energy continues to strengthen, it overcomes the electromagnetic force. Stars and planets are ripped to pieces. Even atoms themselves are not safe. In the final moments, the strong nuclear force which holds atomic nuclei together is overcome. Matter itself disintegrates into its most fundamental components. The timeline for such a scenario would be surprisingly quick once it begins. Cosmologists estimate that once the process starts, it could be over in as little as 20 minutes. The entire universe, from the largest galaxy clusters to the smallest subatomic particles, would be torn apart in less time than it takes to watch an episode of your favorite TV show. The evidence for the Big Rip scenario is admittedly less robust than for the Big Freeze. It relies on a specific behavior of dark energy that we haven't yet observed. However, it remains a possibility that cosmologists take seriously, as it aligns with some observations of the universe's expansion. The implications of the Big Rip are, to put it mildly, catastrophic. It suggests an end to the universe that is both violent and absolute. Unlike the Big Crunch or the Big Freeze, which leave open the possibility of some form of existence continuing, the Big Rip seems to preclude any continuation of our universe as we know it. However, as with all these scenarios, it's important to remember that we're dealing with events in the very distant future, based on extrapolations from our current understanding of physics. The universe has surprised us before, and it's likely to do so again as we continue to explore and understand its mysteries. Now that we've explored these three main scenarios, the Big Crunch, the Big Freeze, and the Big Rip, let's venture into some even more speculative territory. What if the fate of our universe isn't a one-time event, but part of an ongoing cycle? Or what if our universe is just one of many, each with its own unique destiny? The idea of a cyclic universe has roots that stretch back to ancient times. Many early cultures had myths of cosmic cycles of creation and destruction. In modern cosmology, the concept has taken on new forms based on our current understanding of physics. One version of the cyclic universe theory suggests that the Big Bang wasn't a unique event, but rather one phase in an endless cycle of expansion and contraction. In this model, the universe expands from a singularity, much as we observe today. But instead of expanding forever or ending in a big rip, the expansion eventually slows and reverses, leading to a big crunch. This big crunch, rather than being the end, seeds a new Big Bang, and the cycle begins anew. Another variation on this theme comes from string theory, a theoretical framework in physics that attempts to reconcile quantum mechanics with general relativity. Some string theory models propose a brane cosmology, where our universe exists on a multidimensional membrane or brane. In these models, our universe could periodically collide with another brane, with each collision appearing to us as a Big Bang. The cyclic universe concept is appealing in many ways. It avoids the philosophical problems of a universe with a definite beginning and end, and it aligns with the cyclic views of time found in many cultures. However, it faces significant challenges from our current understanding of physics, particularly the observed acceleration of the universe's expansion and the expected increase in entropy over time. But what if our universe isn't alone? What if it's just one of many universes, each with its own physical laws and potential fates? This is the premise of the multiverse theory, one of the most mind-bending concepts in modern cosmology. The idea of a multiverse arises from several areas of physics. In quantum mechanics, the many worlds interpretation suggests that every quantum event creates a branching of reality, leading to countless parallel universes. In inflationary theory, a model of the early universe, our observable universe might be just one bubble in an ever-inflating cosmic foam, with new universes constantly budding off into existence. If the multiverse theory is correct, the fate of our particular universe becomes just one thread in a vastly larger cosmic tapestry. Some universes might end in a big crunch, others in a big freeze or a big rip. Some might have physical laws so different from ours that we can barely imagine what they would be like. The multiverse concept is highly speculative and, by its very nature, difficult if not impossible to test empirically. After all, we have no way of observing or interacting with other universes if they exist. However, the idea continues to fascinate physicists and philosophers alike, as it offers potential solutions to some of the deepest questions in cosmology. As we reach the end of our cosmic journey, let's take a moment to reflect on what we've explored. We've ventured into the far future, considering possibilities ranging from the quiet fading of the big freeze to the violent end of the big rip. We've contemplated cycles of cosmic rebirth and the mind-expanding concept of multiple universes. What's striking about all these theories is how much they reveal about the current limits of our knowledge. Despite all our advances in physics and astronomy, the ultimate fate of the universe remains a mystery. Our theories are based on extrapolations from what we can observe now, projecting current trends into a future so distant it defies comprehension. Yet, this uncertainty is not a weakness of science, but one of its greatest strengths. It drives us to observe more precisely, to think more deeply, and to imagine more boldly. Each new discovery, each refinement of our theories, brings us closer to understanding our cosmic home and our place within it. As we conclude, I invite you to ponder these questions for yourself. What do you think the ultimate fate of the universe might be? How do these cosmic possibilities affect your view of our place in the universe? And perhaps most importantly, how does contemplating the vast scales of cosmic time and space influence your perspective on life here on our pale blue dot? If you're interested in exploring these ideas further, I encourage you to delve into the wealth of books, articles, and documentaries available on cosmology and astrophysics. The journey of discovery is ongoing, and who knows, perhaps some of you listening today will contribute to unraveling these cosmic mysteries in the future. Remember, in the words of the great Carl Sagan, we are a way for the cosmos to know itself. By seeking to understand the universe and its ultimate fate, we are fulfilling one of the most fundamental quests of conscious beings. Thank you for joining me on this journey to the end of time. Until next time, keep looking up and wondering about the magnificent cosmos we call home. This is Dev for Zen Gaming Zone, reminding you that the greatest adventures lie not just across the ocean or on distant planets, but in the farthest reaches of our imagination and understanding.